Okay, so now we're going to look at ionic compounds and how they're different. I have no idea why this picture has been chosen for this. I stole the slide. Anyway, when an atom loses or gains an electron, they become charged. The charged atoms are called ions. So it's an important distinction. We talk about elements, which is both of them. It's a general word. Atoms are uncharged elements. Ions are charged elements. So everybody wants to be noble. Every atom along here wants to be sitting with a full outer shell. All right, that's the first important thing to know. And when we talk about electronegativity, what we're really talking about is that remember, electronegativity is the propensity or the likelihood or the property of an atom to attract an electron, right? So over here, they're going to want to take an electron on before they're going to want to give one off. And over here, they're going to want to give one before they're going to take one. So what does that mean? If they're going to take an electron on, it means that these are going to form negative ions, anions. Right? Because they're likely to take an electron on, they're going to become anions. And over here, they're going to give up an electron, right? And electrons are negative, so once you're giving away a negative, you're going to become positive. So over here, you're going to be cations. So on the whole, metals are cations and non-metals are anions, and that's to do again with that electronegativity thing, right? If you didn't understand electronegativity, you need to go back and watch that video again, because it's a tricky thing, but we need to make sure you understand it, because everything else, well, so much more kind of piles on from it. So electronegativity, high electronegativity means that it's going to attract electrons, become an anion, and over here it's going to repel, or it's not going to be very attracted, so it's more likely to lose those electrons and become a cation. So ionization trend, more likely to become ionized over here, and more likely to become a negative ion over here. Okay. So let's have a look at the electron dot diagrams for sodium and for chlorine. Or these are Bohr diagrams, aren't they? Right? We have 2, 8, 1, and we have 2, 8, 7. For the Bohr diagrams. Now, this one electron hanging out here all by itself means that this sodium isn't able to get its full outer shell, right? And this chlorine isn't able to get another, it doesn't have a full outer shell because it's just missing that one, right? And if only sodium and chlorine could come together, because what's going to happen here is the electronegativity of this chlorine is much higher than of the sodium, so it's going to pull this electron away from the sodium and allow it to join the chlorine. The chlorine is then going to have a full outer shell, and so is the sodium, right? So this electron for the sodium is going to come away from the nucleus. That means it's going to have a full 8 electrons. It's represented here by the 8e negative, full outer shell electrons. And therefore have a full outer shell. That's wonderful. Well, what does that mean for its charge? Well, it's got 11 protons, right? And only 10 electrons, right? So every electron is negative, so it's minus 10, so 11 minus 10 is plus 1. So when we're talking about the charge of sodium, we would notice that it have a plus 1 charge, right? So we're talking about over here, the sodium has donated its electron to the chlorine in order to fill the chlorine's outer shell, while the sodium ends up with its minus 1 structure, right? So what you end up with is the chlorine has an extra electron, right? So an extra electron means an extra minus 1, so it ends up with a minus 1 charge, and the sodium ends up with a plus 1 charge. And if you have a look at this lattice over here, here's what you see. All these chlorines sitting with their minus 1 charge, right? And the sodiums over here with all their plus 1 charges. And they exist in this lattice. They exist in this crystalline form where all the negative anions, the negative chlorines, are held in place by all these positive sodiums, and all the positive sodiums are held in place by all these negative chlorines. It makes it a really rather strong but brittle structure. That's all I wanted to do today. Next time we're going to talk about naming these ions. Have a go at the question, and I'll see you in class.